For now. How's everyone doing? Your body's still awake. Gonna get a haircut. Yeah, I need to get one. We'll get a haircut. We'll do it. We'll do it. Major haircut, minor haircut, I don't know. Gotta figure it out. Gotta figure it out. How's everyone doing? Whew, tell you, man. It's just like busy time of year. Busy time of year. I feel like I need to color grade this again. I'm just getting burnt. Getting. You can tell you, I'm pale. Oh my gosh! The sun! I'm pale. Maybe I am just burnt up here and then I'm just... Friday was a week ago Friday I was out in the sun a lot. I go from like, yeah, I just burn. But with that, be good, take care of your skin. Important life lessons here at Stat 201. We might do all of Chapter 5 quiz. Chilling out. Okay. Chapter 5. Let's do it. Let's do all of Chapter 5 quiz. This is not the right video details. That's not the right video details. Where is my video details? Anyone here? The only one here? Got something stuck in my tooth. I ate some lunch and relaxed.
I'm still talking like Mewbot. Yeah, I fixed it. Wow, I'm glad. I am so glad I actually saw that. It says 3 people are watching, but I would have done this whole video talking like Mewbot. The whole entire video. Mewbot taking over the stream because I forgot to uncheck a button. I still have my ringer on. Good stuff. Got fun stuff, updates happening in Hassel. Well, Mewbot's awake. Grant, good to see you. Bunny in the chat. Grant, good to see you there. I think, yeah, Grant from a while ago, right? Is it Grant from a while ago, I think? So many names. We're going to get the applet up and going. Man, I woke up at 5:30 this morning and I went back to sleep. I almost stayed up. I almost stayed up. Yeah, Grant. That's what I thought. I was like, good to see you, Grant. Like 4 or 5 years ago? How long ago, Grant? It's been a while. But I hope you're doing well. I think, have you graduated? Glad you're here. Throw you some points. It's like, I know who that is. I haven't seen them in a while. I like people swing by every once in a while. They'll see I'm live and they'll be like, I'm gonna go check out what Brian's doing. It's interesting. It's interesting world. I tell my family, I say to my family, I'm streaming online. You should come swing by. And they say, okay. Like, you stream online all the time. You come say hi to me in the chat. Mom, Dad, you there? Brother, sister, aunts, uncles, you in the chat? Cousins? Oh, man. I don't know. I'll probably go check it out if I found out one of my cousins like always streaming on like Twitch or something. Well, let's get serious. Here we go. Stat 201. They love me all the same. Part 2 quiz. Well, do we need to we gotta do the homework first, right? Gotta do the homework. Okay. Let's get the homework out. I don't think we did the homework yet. Did we yesterday? I can't remember. We did. What's up, Abby? Should we do all the quiz or all the homework? I feel like we did the homework yesterday. It's very similar. Let's do it. Okay. So you can see we have the normal distribution calculator up. It is pinned in the chat. You can find it on the Stat1 webpage. So make sure to go to the Stat1 webpage or go to the applet thing Mewbot is showing. Now, what you want to be able to do on the test, there's 2 skills. The 2 skills I would have on the test is 1, being able to draw the curve, and 2, knowing the 68, 95, 99.7 rule. On the test, you could get pictures that are a little bit different. I feel like we did do this one yesterday. We did. I feel like we did the full homework. We did. I know we did these recently. No. We've just done enough of the quiz that this is... I'm seeing things we've done. We haven't done the full homework because the homework doesn't change. All right, so we've done a lot of these, but they're part of the quiz also. That's why I'm remembering them. We haven't actually done the walkthrough of the homework. So why not? We'll do the full homework right here so it's in the video, and people see how to solve it. So when you get a question like this, what you want to do, let me re-timestamp this. Yeah. When you get a question, you want to draw it out. Now, the applet won't be used on the test, as in you won't actually have it. You need to draw it out. And so you take this question right here, and you say to yourself, well, I don't have the applet. I'm going to draw it out. So you start by drawing a normal curve. And then with the normal curve drawn, you put the mean at the center. And a lot of times we do z-scores to start. Yeah, it's not perfect. Yeah, it's perfect. We do z-scores to start, which is a curve with a mean of 0 and a standard deviation of 1. And we go down and up 3 standard deviations. Now you put the context of the curve on here. Very important. We put the context, which is the mean. Where's the mean at? There we go. Really, they put the standard deviation that far away. So the mean's going to go right there. And the standard deviation is going to go right here. As in, we put the mean of 1,152, and then the standard deviation is going to go up by 84. So we start adding 84 to this. You can call it your calculator, or you can like think really hard. You're like, oh, yes, yes, yes. If I make a small math error, it's okay. Just don't make it on the test. And I think we've done it. There we go. Now we start subtracting. Always more fun going backwards. 1, 0, 6, 8, I believe. And then we subtract again. And 9. It's more fun when you do it in your head. So that's going to be 984. Ooh, 900. So good to see you, Allison. Ask questions if you got it. So once again, you can check your math right here. We are literally just taking 1152 and adding to it 84. We're right, we're right, we're right. And we can subtract 84 going back down the scale. You see, these are the numbers you're seeing here. We should see that number. We should see this number, this number, this number. So we've done it. We've gone up and down 3 standard deviations, and we have the normal curve. And so this is said to be normally distributed. I was trying to write. Normally distributed with a mean of 1152 and a standard deviation of 84. So that is the curve. Now we want the percent of steers over 1250. Can anyone take a guess in the chat? I'll throw you 5,000 points for just taking a guess. It's going to be a little bit less than what? Anyone got a guess of the percent of steers over 1250? It's probably actually a little bit further over than that, but it's going to be a little bit less than what? The percent of steers over 1250 is right there. So what is this? The percent of steers over 1250. Anyone got a guess in the chat? We will use the applet for this, but we can take a guess. Any guesses? Yes, Grayson. I got 35,000. And good guess. Grayson and Abby, we're going to guess about 14%. A very good guess, because you're using, just so people are wondering why they made that guess, they're going here with the 68, and then this has to be 16, and it's a little bit less than. So great guess. You bet we'll do that. And we can do that one here next, because you're here. You get to dictate what we do. Always remember, you come to the chat, you ask a question, we'll do it. Next question will be Allison's question. The next question says, and we're going to find the exact answers to these, the percent under 1200. Just take a guess. 1200 is going to be right about here-ish. Anyone got a guess on? You can tell it's more than a certain amount. So our guess on this first one, the blue one, I'm going to guess about 13.4. That's just a guess. Just a guess. What's the guess for the next one, for the orange one? Just a guess. We're just guessing at it. Remember, we're not going to get the right answer. We're just guessing. We could get the right answer. You never know. What's the guess for this one? What's the guess for this one? Just any guess. Just a guess. Any guesses? Just take a guess. I'll throw you some points. Because then when you look at... It's going to be a good guess, Abby. I'll throw you some points right there. Good guess. It's going to actually be less than 84%, because that's what's below -1 or +1. So maybe 70% or so. Something like that. Is that 82, 70, somewhere close enough, right? We know it's more than 50. Good, Abby. I'm 25,000. Good guess, Abby. And the last one says between these two numbers, between these two. So, ooh, this has to be a little bit less than what? Ooh, who's got a good guess on this one? Because we know if you cut -1 to 0 in half, we know what that is. Like, we know this full area here. So this has to be a little bit less than what for this last one? And then we can take a guess at it. Between those two numbers, that has to be a little bit less than what? Because remember the 68 rule? I know I'm got a bunch of numbers on the screen, but we're looking at this blue area for the last one. A little bit less than 34 because half of 68, right? So a little bit, great job. So we maybe could guess just a quick and easy 30% right there. So now we're going to go back and I'm going to try to show it at the screen at the same time. Ooh. You'll see my screen in a second. There we go. Okay. So we go right here and we put in the mean of 1152, the standard deviation of 84. And with this right now, we go above, what is the above? Above 1250. Well, we have to put in find the area using X. So make sure you selected that. And we want to a few decimals. So it's 12.2. So let's go back over here. 12.2. We'll just write the right answers in blue right up there. We want under 1200. And the answer is 71.6. Oh, look at this. This answer over here was 71.6. Nice. We got super close. And then the between on this one, the between is between 1075 and 1150. And look, we guessed 30%, and it's actually 31.1. So it's actually 31.1. We guessed 30%. So in all instances, we were about 1% off. We were about 1%. We were 1.2 off, 1.6 off, and 1.1 off. Our guesses were pretty dark. And you look at the pictures. You see the pictures, like that sliver there. It looks like our sliver there. So once again, we didn't even use the applet, and we got pretty good guesses. Let's go look at those answers that we got. So for the percent above, it's 12.2. For the percent below, it is 71.6. What'd I do? And for the percent between, it's 31.1. We use the applet for the exact answers. Is everyone, who thinks they understand? We're going to do Allison's question here. But do people kind of get the idea that you can draw these out and take some logical guesses at the answers? We're going to go grab Allison's question right here. Let's do it. Does that make sense to people that I want you to be able to draw it out and have a logical guess of what the answer is, to be like, about looks like this. Like using your 68, 95, 99.7 rule, you can kind of guesstimate what is on the curve. And that helps with empirical rule questions and also helps to be able to understand what you're seeing in the pictures. So let's see, Allison's question is, a traffic engineer records the speeds. Is this from Speed, the movie? The bus can't go over a certain speed. Okay, let's go do this. Speed, the movie with Keanu Reeves. Yeah, you can. And the graphic pictures, let us know if there's issues. But here's the thing, Grayson. If it says use the empirical rule, that's when you have to use the empirical rule, the 68, 95, 99.7. So if it says use the empirical rule, make sure to use the empirical rule. So that's when you have to use the empirical rule. Yeah. Because the empirical rule is a little bit different. The integration of the curve with the normal CDF, normal cumulative distribution function, or the normal PDF will give exact answers. But the empirical rule is something we keep with us, the 68, 95, 99.7. And in truth, it's 68.26, 95.449, and 99.7300. So there's even more decimals to it that, like, if you carry them, you'll get exact answers. Empirical rule. Stat 201. What should we do after this question? A traffic engineer. Okay. What do you think I immediately look at in this question? Whenever I see a question like this, what do you think my eyes immediately go to? My eyes immediately go to what? When I know we're doing normal curve stuff, I'm like, okay. What do my eyes immediately go to? It's like, oh, it's a normal curve question. We're dealing with normal curve stuff again. Hey, Mom, we're dealing with normal curve. Hot Pockets. What do I immediately look at for a normal curve question? Here's a hint. Mean and standard deviation. Great job, Allison, right there. Nice job. We look at the mean and the standard deviation. The mean tells us the center of the distribution. Really? The mean tells us the center of the distribution. And the standard deviation, it's because I'm so far at the bottom of the screen, I think I want to go off the screen. The mean tells us the center of the distribution. And the standard deviation is a metric of spread, telling us how spread out values are around that mean. 1 standard deviation, 2 standard deviations, 3 standard deviations contained in it relatively 68, 95, 99.7. So if the normal model is appropriate, how could we find these values of the middle 95%? If the normal model is appropriate, how could we find those values of the middle 95%? Think theoretically here, that how could we find those values of the middle 95% if the normal model is appropriate? If the normal model is appropriate, how could we find these values? How could we find those values if the normal model is appropriate? Like, it's like, if the normal model is appropriate, well, where would the middle 95 be? 2 standard deviations above and below. Great job, Allison. So all we're going to do right now for this first part, and we might have a lot of it solved just using this, is we're just going to go to the mean of 23. And great job, Grayson, also. Drop some more questions, because we are out of questions after this. So if you drop another one, that's 2 standard deviations up. And then I'm subtracting it. I'm going down, because right now we're 1 standard deviation up. We're at the mean. We're 1 standard deviation down. We're below. You can also do mu plus 2 times sigma. So that's 2 standard deviations below. You can also draw it out. Just make sure you look here. If you times this by 2, it's almost 7. 7 plus 30 is, well, it rounds up. And then 7 plus 23, 7 minus 23. Just make sure your math looks like it's mathing. Check your calculator. The accompanying table shows the values. So let's take a look. Now, the middle 95 starts at what percentile? The middle 95 starts at what percentile? It's on the graphic we just saw, but if you think the middle 95 starts at what percentile and goes up to what percentile? Remember, it's the middle 95. So if it's the middle 95, it starts at what percentile and goes up to what percentile? The middle 95, exactly. It started at the 2.5 and go up to the 97.5, which is the area below there. So we can just, great job, Logan and Grayson. So we can grab the values right here from the 2.5 and the 97.5. I can't bring it off the screen, but I can screenshot it, and then I can bring it off the screen to type them in. So make sure you grab those values respectively. The values we are grabbing are the 2.5th percentile, which is the start of the middle 95, and the value right there, which means in between these values, really, what are you doing, word? Go right here, and you have 95% contained within. Let's go put those values into the answer. The lower percentile, the lower bottom, is here. Does that look kind of like our number? As I missed, really. Does that look kind of like the number? Does that look kind of like the number? What do you think? You better not be mad at me for entering these last zeros. Sure. Which are kind of close. So it would be approximately normal. We should not be surprised. Should be good. Yay! What they're pointing out is the theoretical idea of 2 standard deviations is kind of close to your data. I know. How do you know if it's kind of close? Put it this way. When they're far off, these questions will usually make it very, 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 very clear. So if it's really far off, then you would know. They'll throw something crazy like 2 and 50. They usually do something like, oh, these are way off. And so the distribution is probably not very normal. And we should be surprised, because if we thought it was normal, these are not what are to be expected. But that's just saying that the theoretical values of the normal right up here, if it's normal 2 standard deviations up and 2 standard deviations down, should be about there, is close to what you see in the data, because this is the actual data, summary statistics from the data. What else are we going to do? Should we go back? We'll do more homework. Homework. Drop another question in the chat. How's a good one? We haven't done that one in a while. I like doing new questions. Some IQ test? Yeah, of course. You can drop as many as you want right now, and I'll try to, if you want to drop more, because then I'll load them up here. But no, Allison, thank you. We can, of course, do that question. This is actually, I'm not even joking. This is like one of my top favorite chapters to do. Corey's got a lot of songs in his playlist. Corey in the house today. Some IQ tests. Really? You gonna crash on me, my Pearson? Crash out? Okay. Companies. We did that one last time. Is it this one, Allison? Yes or no? Is it this question? I think there's multiple some IQ tests. Some IQ tests. Oh, if it is, I'm gonna get to guess on it. Oh yes. Is it this one right here? NFL data. Nice. Is it this question? Chapter 5, part 2 quiz. Gotta finish writing my papers later today. Nice. Okay, here we go. What you do with these questions is you think really, really hard. You go like, must use all brain power. Okay, here we go. I'm going to try to get these right. If I get it wrong, it's all right. We'll see how close I get to the actual answers. And then I'll show you how I got these answers. What are you going to use? Type it in the chat. What are you going to use to solve these as Brian guesses at them? This is me guessing. Okay, highest 5%. Okay, I've got a guess. My guess is 123. Lowest, 25%. Okay, I've got a guess. My guess, a little bit more than that, is 89.8. The middle, 70%. Yes, applet Logan right there. Use the applet. The middle, 70%. My guess is 84.7 and 115.3. How'd I do? I got one right. I got one of these right, and I just guessed. And it's to one decimal place. Remember that. So I want you to think what I did. Probably the easiest one that looks like I missed. I think I got the middle one right. Okay, so I want you to see how I guessed the last one. The middle 70%, which we must be really close to. We got to be close to the answer on that. No, it's lower? Really? Yep, it is lower. I knew we were close to it. So it's this one we're wrong on. Yeah, I knew it was that one. Well, I could cheat and solve that one. Sure, why not cheat real quick? Let's do that really quick. Oh. Really? Oh, wait. 15 times 1.216. Okay, so it's 119.2. There we go. Oh. Well, let's just get it right. My highest 5%. Oh, 1.645 times 10 times 15. So 124.6. There we go. Okay. I want you to think about this one down below. If this question had said the middle 68%, what would you have done? If this question had said the middle 68%, what would you have done? If it said the middle 68%, what would you have done? If it had said the middle 68%, what would you have done? Does anyone? And what would you draw out? What would be the answer? Just pretend you're like, if it said the middle 68% is found between what and what would you do? Logan, you're on the right track. And like, what would you answer even? So what would you answer if it said the middle 68%? Because don't we know that number? Because isn't it just one standard deviation above and one standard deviation below, which is 85 and 115? So if it's the middle 70, because this is the middle 68, but if it's the middle 70, it should be a little water. If instead it's the middle 70, it'll be a little further out. That's why I went a little further than 85 and 115, because that's one standard deviation is 68%, but then to get to 70, you have to expand it a little bit. And you see it right there. So that's how I was calculating that one in my head when I was doing it. So we're going to go ahead and grab this right here and show how to get the answers. You would type in 100 here and 15 here. The top 5% is also known as the 95th percentile. You can find the top 5% by clicking and putting in 5% and going to the top 5%, and you can even round to one decimal right there. The bottom 25% can be found by typing in 25% and going in below. So there's the bottom 25%, which I was lucky, it gave it to me. I guessed it right. The last one is the middle 68%, and remember, 68% is within plus or minus one standard deviation, and notice it gets wider as we do this to the answer of 84.5 and 115.6 or 115.5. So this is the middle 68%, and then if we go to the middle 70%, it's wider. Does that make sense how to do this question right here? You can do it with the applet. Also, you can try to draw it out like I was doing, where I'm like, okay, this is the middle 68. The middle 70% has to be further out. And I could do a drawing of each one. I also know the z-score for some of these too. That's how I was able to cheat and do 1.645. 1.645, I messed up because, if you're wondering, I know someone's wondering, the top 10% is 1.2816 as a z-score, and the top 5% is 1.645 as a z-score. If you go to the top 5%, which is what it wanted, the top 5%, 1.645. I should do 1.6449 again, but it's 1.645 if you do that. There we go. Any questions? Did you get this, Allison? I kind of did this one a weird way. I wanted to do it more than just plug the numbers into the applet. I wanted to show how I'm theoretically thinking about it, that if this is the middle 70%, I would do a drawing right here. Like, if I'm doing this not with the applet, I'm going to go here and be like, the middle 70% is going to be a little bit more than one standard deviation, where one standard deviation is here, one standard deviation is here, and that's the middle 70. So it's a little bit more than one standard deviation out. Any questions about this one? I try to teach different ways when I do things sometimes. I hope everyone's like, I'm confused. I think we have a few more questions. The other questions are, let me see. I know we have more. There's a question on Canvas content as we get. Yeah, Logan, drop it in the chat. We'll do it. Corey has the songs. We did the bobsledding or the downhill skiing one. The Corey one might be on the. It must be on the homework. Is Corey on the homework? 1992. What's the rest of it say? What's the one? I think there's two of those, and those are really good. They look a lot like the test, so we can do that one next after this. Is the Corey one on the homework? It must be on the homework. We'll do the Corey one, then we'll do this one. Yep, found it. Okay, this is a good mini lecture one too. Chapter 5. Okay. How many ways are there to check normality? How many ways are there to check normality? How many ways are there? Thank you so much. Yeah, we'll do that one. I know which one it is now, Logan. How many ways are there to check normality? Well, there's probably more than that, but like the omnibus test and the Shapiro-Wilk. You're already listing some of them. 3 ways. And Mubot's happy to see everyone here. There are 3 ways to check normality. Here's the 3 ways we've covered. I'm sure there's more, but let's talk about these 3 ways. So the 3 ways to check some normality is, he doesn't know. He's a bot. The 3 ways to check normality are to simply look at the histogram. You take your histogram and you look at it. It could look like this, or it could look like this. So when you look at the histogram, you have basically, does it look normal or not normal? And that's just one way to do it. Another way to check normality is what is called the normal probability plot. The normal probability plot. Now, we put these kind of error bars around it, and we draw a straight line down the center. I like it when the line is red to tell you what it should follow. If it follows the normal, the points will mainly follow a linear pattern. They don't have to be perfect. They don't have to be perfect. They mainly follow the line. If they bend away from the line, they do not follow the normal. The red line is your perfect normal. This is a perfect normal, mostly follows it. This is a perfect normal, doesn't follow it at all. Very, very right-skewed data. So the normal probability plot is a plot that allows us to assess the probability of normal. I think Logan might have mentioned the last one there is a goodness of fit test. So a goodness of fit. Goodness of fit. And what you do is you take the normal and you lay it over top the distribution. So you'd lay it over top and you'd see it's a good fit, or you'd lay it over top and you'd see it's a bad fit. So in this instance down here, this is a bad fit. It does not fit the data well. And when you have a bad fit, the p-value will be less than 0.05, indicating bad fit, and good fit has a 0.05 or greater than or equal to 0.05. So that is the goodness of fit test to check, and I did a big review on this yesterday. Check out yesterday's video for a much more in-depth lecture on it. So let's look. They are giving us a normal probability. What do you think? According to the normal probability plot, what do you think about the normality of that data? See, that one of the ways to do it is to do the normal probability plot. What do you think? What do you think here? Does it follow the line, which is following the normal? Yes or no? What do you think? Then we're gonna do the. What do you think? Does that follow the normal? So there's the normal probability plot. If it, we're in this world over here, so I would say in no way does that follow. It does not follow the line. The line is what is normal, and it does not follow the line, so it's definitely not normal. That is how you do it. If it's not normal, how does it differ? Not on the test. We gotta go to Squidward here. We talk about Squidward every time, just because my drawing kind of looks like handsome Squidward. And so, he's blowing it to the right. Whichever way it looks like the wind is blowing it, like if there was a wind gust coming in, it's blowing to the right. It's also, statistically speaking, there's higher values than what are expected. So this is the expected line right here. That's expected. And if there's a lot higher observed values, because these are the observed values, the observed are a lot higher than the expected, which would look something like this right here. Oh, well, I should maybe draw an observed. This is the observed right here. And the expected is this. So you can see the observed go a lot higher than the expected. So the observed dots I've shown there are a lot higher than the expected, which is the model right there. So there's a lot higher. That's the more statistical analysis, or you can do Squidward. Squidward always lets us know which way it's skewed. Okay, how it bends exactly. There's just little tricks. Like, I mean, if you get into the exact statistical analysis of it, memorization or deep knowledge, either one works. It's a test. If you know it, you know it. If you don't, you don't. I think everything in life can be like analogized to some sort of fun thing. Like when you think about it, there's always like a way to make things fun. Like you should try to turn something into something you can enjoy, like to talk about, to do, to analyze, to understand. So you want to be able to somehow have it be something fun. If I hit back, will it? Do I get a new version? I better get a new version. We got to find that test question. I see it. I bet you, Logan, you're like, no way when I show you how to solve this one. We're out of questions after this. Is there another question? There we go. We found it. Okay. Some normal curve review. Stat 201, Chapter 5, Part 2 quiz in a 1992 article. Canvas content. Okay. So what do you do immediately when you get a curve like this? What should you do on your scratch sheet of paper? What should you do? Any thoughts? What should you do on your scratch sheet of paper if you get something like this? Well, we need to know the notation it gives us first. That is the mean. So that's mu. And the mean would go here. And then here's the standard deviation. The standard deviation is 0.7. That's going to be the units we go up when we do the context. So you always want to label everything. Exactly, Logan. Add the mean, add the standard deviation, label everything. So 98, really? 98.2. Now we go up to 98.7. I've already done this problem a lot. This is enough information to solve it. What does this mean right here? Like, do we have a value for where this is at right here? because it says the middle 60% is found between here and here. So that's what it's showing us, right? But with that in mind, if the middle 60%, well, this says the middle. Help me out with this. Oh, wow. Logan, 5,000 points correcting me. You're right. I saw the 7 and wrote that instead. I see what you're getting at. Great job, Logan. You are correct. And so what do these values mean? Great job, Logan. Good correction. What does 0.842 mean? It says on a curve with these values, like down here. The 0, 1 curve is known as the standard normal. So what are these values right here? They're known as what? Those values, this 0.842 and negative 0.842, are known as what? They're z-scores. So that means right here, this is z equal to 0.842. Now, we can see that this is the middle 60%, and it's symmetric. How much area is total outside of here? Now I'm asking total outside of here. How much area is total outside of here? Not just one arrow yet. I'll do that. 40. So we cut it in half to get 20% and 20%. So now it asks about the 80th percentile. We need to find where the 80th percentile is at. I don't like that color. The 80th percentile. I'm running out of color here. The 80th percentile. So the 80th percentile means 80% of the area is below that point. So we're actually looking for right here. Does that make sense so far, Logan? Because the 80th percentile means 80% of the data is below that point. So if it's the 80th percentile, it means 80% has to be below it. And with that in mind, could you just take a guess at the body temperature? Could you just take a guess at it? Like, what do you think? Just guess. Don't even worry about solving it yet. But guessing often lets us know if we're close to the answer when we solve it. Because if we guess like 100, then if we don't get 100 when we solve, we're like, well, either I guessed wrong or I mathed wrong. So what would you guess the answer is? What would you guess it is? Just a guess. What do you think the temperature is? Any guess? Worth 1,000 points. 98.8. Let's go right here. Let's go back. And let's put in 98.8. And go here and hit submit. Hit OK. And we got it right. Because there's a plus or minus error on it. Would you look at that? We got it right. We guessed it. So let's now solve it. So if we know exactly, we just guessed it. That's all we did. You guys, nice job, Logan. 5,000 points. You guessed it. So what you want to do is we need to take the formula observation minus mean over standard deviation, which solves for a z-score, and just rework it to solve for the y, because we want the y. These are y's on here. Like these are the y's. These are the observed values. So those are all observed values. So we can go back, currently emoting. We can do y equals the mean plus z-score times standard deviation, because that's what a z-score tells us, is how many standard deviations above the mean something is. So we can use this. And we can just solve out that 98.7, there's some extra decimals or so, is 98.2 plus 0.842 times 0.7. Oh my gosh, I went off the screen. But does that make sense? 98.7 equals 98.2 plus, barely have enough room again. There you go, times 0.7. There you go. Yep. Because it's you just rewrite the formula right here. So that's got it. Yeah. And then also, once again, we said you can look at the answer down there and kind of see what it is by doing it. Yeah. Using the normal, the IQs, let's do it. That's the quiz, right, Allison? That's the quiz, I think, or on the homework. Well, let's do it. Let's do it. Question 53, man. Yeah, we can. We probably have enough time, Piper. Let's try. I did that one yesterday. I go right, and I'll probably go to almost 220. I owe my students a lot of cards. In 475. The quiz. You're welcome, Logan. Good work. And thank you. Really big thank you, everybody. I know it's a tougher class. Like, I mean this. I actually failed my first statistics class in college. I was supposed to take intro stats. And I told them, I said, my dad's a statistician. Can I just skip intro stats? And they said, okay. Am I hallucinating? How did How did that appear in a 1992 article? I'm hallucinating, everyone. Ah! I don't know what's going on. It's because I didn't apply myself. My parents said, apply yourself, son. And I said, no. Now I've solved like a billion stats problems. Okay, the question is, use the... What? This is it. I don't even know how I found it that quick, but it appeared. Okay, use the normal model. Okay, step one to any problem like this, what do we do? What do we do? Step one for any problem like this, what do we do? Joey from Full House is here to tell us to what? I should make that a thing on the soundboard. What do we do? You can go to the applet. That's a fine answer. Let me throw you some points for that. You can go to the applet, but I like to draw it out. Draw it out. The 22nd percentile. So we're going to go right here. We're going to draw out the curve. Gotta make the noise. Only draws if you make the noise. And we go down. You go up and down 3 standard deviations. If you draw this curve a bunch of times, you'll get to the test. You'll be like, I got this. I've drawn the curve so many times. Now, below the curve, we put the whats. Tell me real briefly for some points. Draw it out. And you can go to the applet too, because that's how you'll get the exact answers in a moment. Below the curve, we put the z-scores. Good. Not blocking it. There we go. So the 22nd percentile, is that over here in the orange area? Or is the 22nd percentile over here in the blue area? Which one would it be? O or B for orange or blue? Is it over in the orange area somewhere? Or is it over in the blue area? The 22nd percentile. The 22nd percentile would be where? Where would the 22nd percentile be? Any ideas? The orange, yes. Because the 22nd percentile means 22% of the area is below that point. So it's actually probably going to be somewhere about here. How do I know that? Well, according to the 68 rule, 68% is between there and there. And if 68% is between there and there, that means 16% is below here. So the 22nd percentile has to be a little bit higher than the 16th. Does that make sense? So maybe about 90 would be a good guess. So 90 might be a decent guess at where it's at when we look down on the Q line down there. Just a guesstimate. Now, where is the 97th percentile? Well, it's on the other side of the curve, the high side of the curve. So the 97th percentile is going to be on the far edge of the curve, way over here, right about here-ish, at about 123. Now, if you're wondering, you're saying, Brian, that doesn't look like there's a little remainder of 3%, because if this is the top 3%, there's 97% below there. But remember, the top 2.5% begins there, according to the 68-95 rule. So 123 might be a decent guess for where that's at. The IQR actually has a trick. If you're wondering how I do this trick whenever I solve what the IQR is, you can actually take the standard deviation and times it by about 1.33 because the IQR has z-scores of negative 0.674 and positive 0.674, making it almost exactly a length of 1.33. And you can even round up a little bit. So if you take this and do 1 1/3, you'll get, if you do 1 1/3 of that, you get about 16. That's just a trick for it. That is not something to memorize. It's a trick. So it's probably about 16.1 or so. So 16 point, we got 90, 123, and 16.1. So 90, 123, and 16.1. We might only got one right. We only got one right. That's what I thought would happen. So we're going to go to the applet right here, and the applet's going to give us the exact answers. So I'm going to put the applet on the screen at the same time as this. Wait 1 second right here. And once again, I really like to draw it out to practice because the applet's going to make it too easy. It's almost too easy working with the applet. You go here and you put your mean of 100, your standard deviation of 12, and then you say we're going below a point, so the 22nd percentile, and that is 90.7. We can even round it to 1 decimal point. And then the 97th percentile, which means 97% of the day is below it. We were right if you round up, so we were close. And then the IQR is the between, and we do the middle 50, and you subtract these two numbers right here. So you actually have to mathematically go and take the two numbers, which is Q1 and Q3 seen respectively there, and do Q3 minus Q1, and that was the one we got correct. I should round up a little bit more. How's that look, Allison? Does this make sense? You should be able to kind of draw it out. This is the one we did draw. We draw out the first few answers here. So will it? No, it's not going to do it properly on the screen. I wonder if I can get it so it can show the previous answers along with the drawing. Trying to get it. Can I go back in time here? Below. So there's the 97th percentile, which I did is the top 3%. Top 3% is the same thing. You can see it over there on the edge of the curve. And then the below, the 22nd percentile right there. There was my first drawing. How's that look? You can see the drawing right here. And you can see the drawing over there. And then the blue drawing is where I did the top 3% to do the 97th percentile. So I could have drew it differently, but if 3% is above here, 97% is below there. Any questions? We have I think the 53 men downhill. Yep. And let me know if none of this, there's different ways of learning it, but I always like to draw it out. I don't want you to just plug it into the applet. I mean, you can. It'll show you the answers, but then you should be able to draw it out. Notice, once again, I can draw all these out, and the middle 50% would be between tighter than 1 and -1, because the middle, really, the middle 50%, which is the IQR, visually speaking, has to be inside of the middle 68. So the last one here, the purple one, is something like, it's 6.67 standard deviations out. It's about there and about there. So that's the length of the IQR, because it's less than 68, because 68 is 1 standard deviation, 95 is 2, and 99.7 is 3. So I had to take a test on this recently. My wife's like, you did fine. I'm like, I hope I did fine. I hope I did fine. A lot of the questions are very similar. If it's like, this one's a little bit different, but a lot of them are very similar. That's still similar. Let's do it. This might be one of our last questions, or if anyone has one more question, we might have time for one more. But 48, 43, chapter 1, chapter 5, part 2, quiz 53 men. Okay, the first part of the question actually has us use the applet again. What one letter can we use to figure out how odd something is, which is observation minus mean over standard deviation? I'm going to find it now for you. Let me mark the question too while I do this. What one letter thing can we find which standardizes things to find out how odd something is? What one letter thing can we find? What's the letter? Something score. Standardizes things to let us know how unusual something is. 108 observation minus mean over standard deviation. 1.709. That is Z-score. Piper knows. So that is 1.709. What do you want the area above this? This could be somewhere between 5 and 10%. Probably about 6.3. And we can find on the applet the exact. So we're going to take that Z-score right there and go back to the applet. And we need to be on the 0, 1 curve. We might not be right now. We are not on the 0, 1 curve. So we're going to go 0, 1 for Z-scores down on the bottom. So now, and even notice it changes to Z-scores when you have the 0, 1 curve. And now we want to go find the percent using X. And we want to go above this number. And the exact answer is, oh, it's between 2.5. And yes, it is. Okay, I was off. It might not look, I should have been closer. It's 4.4. It's between 2.5 and 5%. Statisticians will know why. Because of 95% confidence interval is 1.96 and 90% confidence interval is 1.645. What is the actual percent of times greater than 108.43? Well, to do this one, let's look at the data. How many times are actually greater than 108.45? How many times are actually greater? This is the actual data now, not the theoretical normal. How many times are actually greater than 108.45? Someone answer in the chat for points. How many times are actually greater than 108.45? How many times are actually greater than that? Anyone know? How many times are actually greater than that? Here's a hint. Beep. Here's another hint. 5. Great job, Piper. So it's 5 times greater out of the 53. So that's 5 times out of the 53, which is something like 9.8? 9.7. 9.6. 9.4. I had my energy drink. Sorry. 9.4. Now, those answers are not too similar. When we look at this right here, these answers should agree if the data follows the what. These answers should agree if the data follows the what. Don't look at their answers, just think. We use the what. So these answers should agree if the data follows the what. Don't even look at their answers, though. Just think. The answers will agree if the data follows the what. The answers will agree if the data follows the what. The normal. Yep. And the normal is a unimodal symmetric curve, so the distribution must not be unimodal symmetric. This one is a tiny bit tricky. You have to think about how the data looks. And where you see a bump is where you should see a lot of the values. This one is uniform, which means flat. It's not perfectly uniform, but it's flattish. This one has a bump around 106. This one has a bump around the high numbers. This one has a bump around the low numbers. If you notice here where it says like 111, 109, 108, it's not a bump around the high numbers because there's not a lot of 108, 109s. This is how many there are. The higher the bin, the more there are. Where's the bump? Like, where do you see a lot of repeating, like, is the bump around 100? Is the bump around it's not around 106. Where does the bump look to be where a lot of the numbers repeat around that? Like, where does the bump look to be? Great job, modeler answer. Where's the bump look to be? The bump would be where a lot of the modal area, the modality, where a lot of repeating numbers occur. Where would it be? Where's the bump? Where there's a lot of repeating numbers. And you can see, like, is the bump around 110? Is the bump around 106? Is there not a bump? Is the bump around 102? The bump. What do you say? We're just looking to see which numbers repeat a lot, which shows a lot of observations that would be around that area. Like, is there a lot of 108s? At the beginning, nice job. Yeah, there's a lot of 100s, there's not a ton of. 101s, there's a bunch of. There's a lot of 101s, 102s, some 103s. See, it starts to peter out here at like 105, 106, 107, 108. So that means this is right skewed data, and you know he's back. You know him. You love him. The Monster Man is here. Once again, right to the high, left to the low, whatever way the Monster Man's tail goes. Monster Man. There's the Monster Man right there. Right to the high, left to the low. Whatever way the Monster Man's tail goes. When we say right, we are talking about right skew, and high, we mean high numbers down here on the number line down low. Not low, left side, you get what I'm saying. Right skewed data has a right high tail, so that is definitely some right skewed data, unimodal and right skewed. Yeah. Any others? We have time for maybe one more, or I might go do a walk. You gotta go outside. You gotta get fresh air. Oh my gosh. It feels like Thursday. I'll tell you that much. I'm gonna finish writing my proposal for a project today. Proposal. Look at all these things. I don't think I have any urgent emails. Thank you so much. I really appreciate it. We're gonna do a lot of cool things. A lot of cool stuff. A little chill music, right? Student asked for a link. I'll make sure they have it. Yay! Piper, you're the best. I appreciate everyone so much. We'll go to the main screen while I chill. I really appreciate everyone here. I love teaching. It is like the best thing in the world, especially when you get students who come back and like I was in the student union and someone was like, Brian? I was like, hey, and they're like, I haven't seen you in 7 years. And I was like, oh, what's up? They're like, so good to see you. And it was really nice. Yeah, really, really nice. Well, with that, gonna take a quick break. Be back here next time on Statue 1. Bye!